So, good evening, good afternoon, good morning to one and all present here. So, I'm Pranav, and then I took part in this internship program which was conducted by WSA, and I'm really grateful for this opportunity. And yeah, the goal of this internship was to build a full stack application from scratch, like implementing the backend, writing all the code without white coding, without using AI. Obviously, AI help will be there for understanding and all, but the teacher or the mentor, Rohit Kumar sir, was exceptionally good at teaching us the concepts, which I internalized it, and along with him, along with his guidance, I've built this project. So yeah, again, the goal of this internship was to gain a wide exposure of how full stack applications are built from scratch. Using MongoDB, ExpressJS, React.js, Node.js, which is called as non-stack again. People used to tell that a lot. So yeah, so I've built a full stack application using non-stack, which is a music player. As you can see here, uh, I've built a music player application like this, and I shall be demonstrating my learning through this. Yeah, whatever I've learned, I will be uh, showcasing, demonstrating, and whatever code I've written, I will be explaining what I've done, why I've done, so that I can display my intellect or whatever I've learned through this. I've just not copied code. I've just not, copied repositories. No, I did not do that. I sat and then like just like everyone, I put in my work and then read the efforts. I mean, read the rewards for this. So that is in front of you all, everyone. Respected judges, or yeah, the judging panel. Thank you for this opportunity, and this is my full stack application. Now, this is the project demo, and then yeah, this is the project. So we'll start off with sign up. Let me create an account. Uh, man123, and then with this to man123@gmail.com. I'll give a random password, and then this will create an account for us. The internet is kind of slow from my side. Apologies. So now we have created the account. Uh, Let me show the login. Now the same 123@gmail.com. This should work. So the login is also working, and now we are going to search some songs. Rock. When we enter the rock tag, rock search query, it is fetching all the songs from the rock tag, and then it is displaying to us. Small food. When we play this song, it will take a while for it to load, and then once like this, we will put it into the favorites. Now it will be displayed inside the favorite. We can play the song from here. Again, it will start playing. And now, if we click on any playlist, we have multiple songs here. If we click on one, it starts playing. So the playlist is also working. We can go to the edit profile. It auto sets, and then if we click on, if we change some field, it changes. Now our username is 124. Let me test out. Forgot password. System123@gmail.com. Reset link has been sent, so let's go to mail trap. We are using mail trap for this mail services. We'll log in. So, what does MongoDB mean? MongoDB is a NoSQL database, which means it stores data not in the form of tables or rows. It stores data in the form of collections and documents. As you can see here, it uses collections and documents to store the data. For example, user ID, song name, and all those can be documents. Then, uh, uh, like it accepts whatever input or data that you give. It does not expect you to structure it and give it to you. That is the speciality of a NoSQL database like MongoDB. So it has a flexible schema again. You can store whatever you want or whatever type of data you want. It will be internally converted to JSON, and then in the form of JSON, like documents, it will be stored. Okay, like user ID right now. Like you get the point, right? That is JSON type of data or document. Okay, so it is MongoDB can be easily integrated with Node.js and Mongoose. What is Mongoose, you may ask? So Mongoose is an object data modeling library. Like you may ask why we use Mongoose. So Mongoose first of all helps you to query MongoDB easily. So ODM, like again, the object data modeling library means it maps JavaScript objects to MongoDB documents. uh, the user ID, all those are documents, right? So ODMs helps us to map JavaScript objects like JSON into uh, MongoDB documents again. If you use the official MongoDB, okay, MongoDB internally uses many querying uh, uh, type of language or semantics. We don't need to use that when we are using Mongoose. Uh, for example, in MongoDB for querying, and if you take SQL, we have a lot of query type of languages, right? Which we use. We don't use that usually when we are using Mongoose, but if you are going to use MongoDB, then we might have to use find, insert one, update one, delete many, and all those things. We don't usually use this in their real day-to-day life because of the implementation of or with the help of Mongoose. Okay, so Mongoose also helps us to provide a schema for the MongoDB data which we are providing, because MongoDB data, MongoDB essentially has no structure, but we have to provide structure. Why? Because large large applications need predictability. Without predictability, it will be like very very confusing for the upcoming developers, whomsoever is reading the code base. It will be very difficult. So we use Mongoose to intentionally reintroduce schema. So for example, you may take a look at what code would be looking like if you don't use MongoDB, Mongoose. So here you can see we are importing the MongoDB package using this require, and then we are destructuring. So if we import the package, we will be getting a lot of things. We only need the Mongo client, so we destructure it from the package which we are getting, or the object which we are getting. As you can see, the MongoDB package exposes multiple things. We are extracting only the Mongo client class. Okay, so we are only extracting this Mongo client class using again destructuring. So and then uh, we are creating a Mongo client instance because there's a class and then you need an instance, alright? So URI is like a connection string. We usually put this inside .env. So yeah, we'll be looking at all those things later. And then we are creating a database, or we are selecting the database rather, and then feed no initializing it with this variable inside this variable. Uh, so now uh, we are we can know these are just like how things work. db.collection.songs, like it'll give us all the songs. uh, if we give inside this find like a specific song name, let's say song name by Adele, so it will only fetch that song and give it to us. But since from this songs inside this database, the songs we are getting all the songs because of this empty string which we have given inside the find. We are not giving any specific string, we are giving this empty string inside this find. So this is an example of without mongoose, and with mongoose life becomes a lot easier in this complete within one line. You don't need to go through all this boilerplate. So yeah, mongoose makes the life a lot easier. So now we are going to be we now know what is MongoDB and then mongoose, why we are using mongoose. So mongoose is used to make our lives easier by uh, figuring out a schema for MongoDB, and then reducing the boilerplate by and then simplifying the queries. So now Express handles HTTP logic, similar to how Mongoose helps MongoDB. Express helps Node.js. Node.js, what is Node.js? Node.js, JavaScript usually runs on browser, and if you want to run the JavaScript code somewhere else, you need the help of, or rather, on a server, you need the help of Node.js. So Node.js code, helps us create servers, and then a lot of things which we'll be covering later. And yeah, Express handles HTTP logic. So Express is like a framework for Node.js. Node.js is a runtime, and then Express is a framework which simplifies the Node.js code, which we write to create and then maintain a server. So now we are going to create a simple server with one route. Like within the URL, we are having this slash hello, and then it should return us hello world. Okay. So now without Express, how it will look like? We are importing the HTTP modules inside this, and then this would give us like a call, this callback function, this http.create server, this creating server thing takes a callback function as input, and then this callback function hits like every time uh, this callback function runs every time a request hits the server. So request is usually request and response, that we know that a request response cycle, and then uh, we get like the request method and then the request URL, or all usually we don't write, we complete it within one line using Express, as you can see here. uh, uh, See, app dot get the request method, and then the request URL, request response cycle, and then it should return a JSON object. It should be converted to string, and then yeah, so the response would be of JSON type. All these things are written like within one or two lines, but in raw Node.js we have to go through all this boilerplate, and then it will take a lot of time for us. And then we need to also mention the header, like what status code it would return, and then what type of content it should return. Like the content type should be in a JSON format. As you can see, it tells the browser sending JSON data. We'll be sending JSON data now, and then headers are metadata about the response. Like without correct headers, the browsers won't be able to interpret the data properly. So, and then the response should be stringified, then hello world. All these are done automatically by Express for us. So manual checking of request method, manual checking of request URL, now setting headers, setting the status codes, and then handling 404, stringifying the JSON. All the manual works are done easily using Express. So Express is a framework which simplifies the server code, or rather the Node.js code we should be writing to create server, and then maintaining the HTTP requests. So that's it for now. So Express is used to create REST APIs. So yeah, we are creating APIs basically using Express with the help of Node.js again, handling routing, handling authentication, connecting front-end database. All this will be same. Okay. So we will now take a look at all the dependencies that we have installed for the backend to work. Uh, so let's start with Axios. Axios is a promise-based HTTP client. It lets our app talk with other servers. So if there are other servers, it allows our app to communicate with them. Like if a backend calls an external API, Axios sends HTTP requests like get, what, and whatever HTTP requests which are available, and then handle the responses cleanly. So it basically does the work of fetch, but it is the abstraction is even more even higher, and then it handles the responses and the HTTP requests cleanly. So we'll move on to the next dependency, which is bcrypt. So what is bcrypt? Bcrypt is a password hashing library. We don't usually store the password in the database just like that. We need to hash the password because of various reasons. So the bcrypt dependency adds salt automatically, like random data to prevent rainbow table attacks, and then the bcrypt is hashed passwords are intentionally slow to prevent brute force attacks. So yeah, next we move on to the next dependency, which is called CRS, of course. Browser blocks requests from different origins unless otherwise stated or explicitly allowed. Like for example, the backend is in localhost 5000 and then the front end is localhost 5073. And then if this front end requests a data from backend, without cause the browser would say no, not allowed to access. So but with cause we will be mentioning that this is the backend, this is the front end, the data can flow. Like for example, let's take the example of an Amazon website and then other databases. So Amazon website and then Instagram, for example. We have uh, Amazon frontend and then Instagram backend. Can we access Instagram backend from Amazon frontend? No. The CORS policy for while making Instagram, they would have mentioned only the URL of Instagram frontend can access the backend of Instagram. No other frontend can access Instagram backend. So similarly, only if mentioned, this frontend can access this backend with the help of CORS. Otherwise, the browser would block, explicitly not allowed. So then we'll move on to crypto. This is which you can see here. So crypto, we use bcrypt for password hashing and then crypto for token hashing. We will be generating tokens like JSON tokens and then we'll be hashing it with crypto. Simple as that. So we will then move on to .env. So we have environment file, .env file, and then we'll be storing our environment variables inside that. And then we don't usually like say const secret is equal to super secret 1 to 3 or something like that. Hard coding secrets is not a good practice, so we make use of .env file, store secret private keys, public keys, and all those things inside that. And then whenever required, we in the other files we just make use of .env so that this .env dependency so that we can access all these .env files and whatever inside this, so that yeah, like in this way process.env.jw underscore secret, and then it keeps all the secrets out of GitHub. So while deploying, we don't usually hardcode all the keys, uh, and we make use of .env file so that we can access all those keys which are written secretly within the .env file can be accessed by our backend or front end with the help of .env elements. So we'll then move on to stateful authentication and status authentication. In stateful authentication, the server creates sessions, and then each time you make a request, the server checks whether you are logged in by checking whether the session is still there. It creates a session and then it stores in the memory or database, and then the session ID or cookie is sent. And now whenever I make a request, you send the session ID. I mean, I send the session ID, and then server checks its storage whether the session ID is still there. And then if the session is found, we are allowed. Otherwise, we are not allowed. So every single time we make request, the server goes back, checks the storage whether we have no whether the expiration time is not completed or something like that. So session based stateful authentication, not a good thing. Uh, so we then move on to stateless authentication. So what happens is the server, once we log in, the server verifies our password. It creates a token. The token contains like our user ID, expiration time, password in some cases, or role, and all those things are contained within this token, and then it is crypted with the help of crypt library, and then the server verifies so okay, and then it gives back the token to us, the JWT token to us, and then with our every request to access the protected routes, we send that token with our within our headers, like authorization headers, and then the server verifies the signature, and then if valid, it acts as grants. Okay, and now the server does not store anything. We are just the server creates a token, then we send the token every time, and then server checks whether the token is right or not. So that is it. The JSON Web Token creates and verifies JSON Web Tokens used for authentication. So after installing all the dependencies, and then I moved on to creating the user model with the help of Mongoose, and then bcrypt for password hashing. So as you can see, the name must be of this type. It must be verified whether it is required or not. And then email ID type should be string, and all those things for all the different cases or all the different documents in case of MongoDB. Uh, so the Mongoose, with the help of Mongoose, we are creating a schema for the MongoDB collection. Okay, so that's it. And then we are telling us how the pre-save function for password must be done. Like uh, we were discussing about bcrypt, like how password hashing must be done before storing the password inside the database, so that we can prevent rainbow table attacks or brute force attacks. So we need to pre-save the password. As soon as the user enters the password, we must uh, encrypt the password with the bcrypt, and then we have to pre-save the password. We need to hash the password before saving it in the database. So not even the developers know the password. No, in the cases of banks, the developers themselves do not know what the user or the customer might have set as the password. So this pre-save function will be used for creating the salt using bcrypt, and then hashing the salt with hashing the password with the created salt by bcrypt again. Uh, and then when required, we will be comparing the password with the entered password in other cases. So if it returns true, the bcrypt will be used to compare again. Uh, and then that's it. And lastly, this mongoose.model will create this schema named user schema. As you can see, in the name of user, creates a model called user from the schema which we have written. So now this gives us class-like objects. So we can do create user.create, user.find, and all the other features. Okay, so now we move on to how we send the email when the reset password is clicked. Okay, so we are importing node-mailer and .env. So what is node-mailer? Node-mailer is this import node-mailer from node-mailer will send the node-mailer library. So node-mailer is a Node.js package that knows how to talk to mail servers like uh, Mailtrap or something using or some other mail services using SMTP, which is Simple Mail Transfer Protocol. So basically, Node is a Node.js package which knows how to talk with mail servers like Mailtrap using Simple Mail Transfer Protocol. So .env, we have discussed about .env before. It pulls in all the environment variables from the .env files and then converts to process.env, and then in case of the process.env to access whatever environment variables which we have stored inside the .env files, and then the .env.config this time is again load the variables from .env files into the memory so that we can make use of process.env to access them. And then now this is an async function. So basically this async await is used because it pauses the execution of uh, whatever we are doing, like the reset password, until the email is sent. So it pauses the execution until the email is sent. Since this is async, it won't block the whole server or wait asks to wait the server. It just asks to wait the server. Okay. So now we are creating a transporter. A transporter is a mail sending engine. It communicates with the mail servers like Mailtrap using the configuration which we have given. So a transporter is a mail server engine which has all the authentication, all the configuration, and then it communicates with the mail servers and then sends a mail. So what is this? Process.env mail trap first. This is the mail server address. This points to Mailtrap's SMTP server. Okay, and then this port is where the SMTP server usually listens from for Mailtrap. And then this is authentication. And then we are sending the mail like from to subject test and all. We are you know uh, 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 cunningly destructuring whatever is required for us from all the options available are given by the mail trap, like to subject and HTML. And that's it. Uh, so hello everyone. Now we'll take a look at the auth controller.js. So first we are importing the user model from user model.js. From here we are exporting the user ID. We are importing that here in the auth controller, and then we are importing the image kit package or modules from the config which we have written here. uh, Inside this we have written the image kit config. So as you can see, so we are importing that. And then now jwt.env cryptos and mail, we have discussed about this earlier. So now let's move on. We are creating a token when the when a user ID is provided, a token is generated with a JSON web token is generated. The JSON web token will be a signed token, wherein it will contain the user ID and then a secret, as you can see here, and then the time it expires. So this will be so along with these three, a signed token will be generated, and then this ID user ID is visible if decoded, and then it is just signed, not encrypted. It is done intentionally, and then like this a token will be generated for us whenever the user logins. We can think, and then this is the sign up express route handler. This is a route handler. So we are in this is an async function because we are going to be contacted in the database, and then it has request response cycle since it is an express route handler. And then inside the try catch block, from the uh, from the request body, now we are now destructuring the things which we require. So we are not importing the whole request body. We are just destructuring whatever is required for us. And then if any of them does not exist, we can just tell it's required. And then we are checking whether the user exists in our database or not. For that, we have destructured the email ID here, right? Now we will be sending that as a parameter for the function which is provided by Mongoose for the model which we have created, which is the user. And then we'll be storing the answer inside this. And then if the user exists, we tell the user exists. And then uh, if an avatar exists, what we'll be doing is we will upload the avatar to the image kit, and then we do image kit dot upload, which returns an object for us, and then we grab the response URL and then save it in the database. As you can see here, in image kit media library, we have this Mun music player folder, and then inside this we store the avatars, as you can see here. uh, and then uh, this upload response imagekit.upload will give us an object like this. We'll grab the URL from this, like upload response.url, and then we'll save it inside this other URL. Or else what we can do is we can collect the upload response object and then destructure the URL alone. We can do that as well, perfectly valid. And then we store the URL inside the database. Now, if there is no user during the time of login or sign up, what we can do is create a user. We create the user by pre-saving the password with the pre-save hook, like hashing and all those things which we have discussed in the user model.js. And then since id is the primary key, we denote it with underscore id. We will make use of the create token function here, and then we will create a token for the user, which we have newly created by passing the id. This create token takes in id as a parameter. That is it. Yeah, here. And then we'll move on. We will say the user has been successfully created, and then we'll send a response like all the user details and all. Either we'll say sign up not successful or sign up successful, sign up error with the error. And then we'll move on to cons login express route handler. As I say, the request response cycle and all those things. This time we don't collect everything because it's just login. We only need the email ID and password, and then we destructure it. And we see both of them are present or not. Even if one of them is not there, the server is going to reject it and then return back the rejection and then the error. And then we will move on whether we'll find whether the email ID exists or not by making use of the mongoose function with the model which we have created, and then we'll store the response here. If the user exists, if the user does not exist, or the email ID does not exist, we'll see the email ID does not exist. And then we'll move on to comparing the password. In the user model.js, you can see we have written a function like this which compares the password. So the bcrypt will be bcrypt will be hashing the password. So to compare whether another entered text or a password is the password which we have stored in the database, we need to make use of this function, because we don't usually store the password as it is, right? We store the hashed password, so we do that. And then mm, if the password is not matched, we say invalid credentials. And then if the user is successfully logged in, like the credentials are correct, we say create a token now again. JSON web tokens. We have discussed about stateful authentication, no, stateless authentication as well before, and all those things, like how it responds back and all. This is a protected controller, which means uh, now it will give access only when we have logged in. If the user does not exist, we say it is not authenticated. If the user exists, we uh, uh, just display the user details. And then this is a forgot password route handler. And then uh, we take in the email ID from the body. And then if the email ID does not exist, we say email ID is required. And then we check whether the email ID exists in the database or not. And then we create a reset token using the crypto library, and then we hash the token as well, and then we store the hashed token inside the database. But why not store the raw token inside the database? If the hackers get access of the database, they might steal the reset token from our database, and then they might reset the password. That's not what we want. So we create a reset token using the crypto, and then we hash the reset token, and then we store it inside our database using that reset password token. And then what we do is we also store when the reset token will expire, and then we save it inside our database. And then we will generate a reset URL using the reset token and then the front end URL, so that when the user clicks, they'll be redirected, and then they can reset the password. Now the user will have access to the reset token, raw reset token, because if only if they raw reset token is available, they can go to that link and then access it. So yeah, then we send a mail using this. The reset URL will be sent. They will click it, and then the password will be changed, and then the password reset email has been sent. Something went wrong. Now, how the reset password will work? We will collect the reset token from the parameters. Like, suppose the front-end URL is this way. Front-end URL, reset password, reset token. Now, it will look something like this: reset password ABC123 token. So, the express route might look like this: post reset password colon token. So, like that. So, whatever is after this slash will be taken inside the token. So now when we do request.params.token, we will get this token. So we will destructure it from the request.params, and then we will destructure it, destructure the password from request.body, because when the user clicks the reset URL, they'll be redirected. They will enter that new password, and then it will be stored inside the body. We destructure the password from the body, and then if the password does not exist, or if the password length is less than 6, we tell no, do it properly, and then we hash the reset token again, mm, and then we check whether we go to the database and check whether the token which we are currently using is greater than current time or not. The expiration time must be greater than the time which we are currently. Suppose it's 9:16, the should not reset token should not expire before 9:18 or something like that. So yeah, it should be greater than 9:16, and then uh, to compare whether the token which we are sending through the URL is the same token which we have stored in the database. We hash it and then compare. So yeah, this way we check whether the hash token matches with the one derived from our URL or not. And then we either say the token is invalid, or if it is valid, we update the password in our database, and then we set the other things to undefined, so that yeah, and then we send the responses. And then this is the edit profile construct express route handler, and then if the user we collect the user ID from the user and request user, and then if it does not exist, we say the user is not authenticated, and then uh, we ask the user to enter in the details like new name, new email ID. I mean, everything is not required to be entered. Like email ID alone can be entered, name alone can be entered, avatar alone can be entered, but new password and current password must both be entered together. So yeah, so from the request.body, we are destructuring these. If a name exists, we are going to update only the name. We are not going to touch anything else. Similarly, if the email ID exists, we are only update the email ID alone, not, not anything else. And then here both must exist. Current password and new password must exist. If either of them does not exist, then we're going to say both are required. And then this match, we will compare the current password with for the one existing in database. Further, we will make use of the compare password function from user model.js, and then if it matches, current password is correct, now you can reset the password, and then we ask them to enter the new password. It must be of greater than length 6, and then yeah, we will update the new password here. And then similarly, we will if an avatar exists, or they are changing the avatar, we will store them inside the one music player, and then we will generate a URL using all these, and then we will upload the upload avatar dot URL inside the user avatar, so that inside the database, and then we will save, and then comment responses, and then we are exporting these route handlers. That's it. So we will now be discussing about the sound controller JS, and then first, this is the get sounds route handler. Here we will be doing this request response driver cycle, and then again, what is Axios? Axios lets us talk between different servers. Suppose we want to talk from our server to song Jamendo server or the image kit server. So it lets us talk lets us talk between different servers. So that's what Axios does. So now we are getting this response. Axios.get will give us the response. We will be collecting the response here, and then what does that? This tracks is the endpoint, and then we are setting the client ID. The parameters are set this way. Client ID, API key for API authentication key. The format should be JSON pretty, and then it should for this JSON pretty is like written in JSON format. And then we should only get like 15 songs now, like written only 15 songs. So basically the backend is saying from the tracks endpoint, yeah, I'm sending you the client ID, and then I'm sending you what format to give me the output as, and then I'm sending you only like limit as 15 songs. Give me the 15 songs from the tracks endpoint. That is it. And then we are getting the response, which will be an object. This access.get will give us the object. Now the object might have different things like data, status, headers, and many other things. So we only need the data, song data. So what we do is song data is equal to response.data. From the response object, we are only getting the data. So uh, yeah, let's move on to the get playlist by tag route handler. Now here we will be either sending the playlist as request.params.tag or request.query.tag or nothing. We are not going to be sending anything. So the possible inputs in the URL can be /playlist/rock. This will be request.params.tag. Or we can send this way /playlist question mark tag is equal to rock. This is sending the request as query. So request.query.tag will be this way. Request.params.tag will be this way. This dot tag is rock. Again, the dot tag will be this way. So if there is no tag, then we'll be saying missing tag parameters. Okay, and then we will be we also saw the limit earlier, right? So if the user sets a limit, like say to 20, we will set the limit as 20. If the user is not setting any limit, the number of songs is if it is not provided, then we will set it to default 10. Okay, so we are now constructing, and then this is the client ID for us in the Jamendo, and then we are constructing a params. So client ID format is JSON pretty, tags is rock or whatever, and then the limit. So example parameter can be this way: client ID format JSON pretty, tags rock, limit 10. Now with this parameters we will be constructing a URL. Okay, this way https blah 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 blah, and then we are going to be setting our own parameters which will override the URL, and this URL might turn into something like this. Yamendo.com tracks the endpoint, the tag is rock, and then 10 songs must be fetched. So as per this parameters, this URL can be changed to this way, and then we will be getting the response now from this URL instead of this URL. And yeah, so basically there is a baseline URL like this. This is the base URL, and then by constructing our own parameters, we are overriding this URL as this URL, and then getting response from this URL and storing here, and then we are getting the data, and that's it. Yeah, this is get playlist by tag error. So tag, yeah, and then we are going to be doing toggle favorites now. So if the user is logged in, we will check whether the user is logged in or not, and then request.user. Then we'll store the user object here, and then usually request.user usually comes from authentication middleware. Okay, and then the middleware might look like this. First we'll verify the token, and then we'll decode the JWT, and then we'll attach the user. So now the user might be the logged in user. Okay, and then from the request.body, which is the whole object, we are only in need of the song object. We will store it inside this song, and then if favorites exist or not, we must check it. Sometimes in MongoDB documents might be undefined, so we are ensuring whether this exists, and then it is an array. So the favorite must exist, and it must be of array. So with this line we check that. and then we are setting the user dot favorites to initially z null if it does not exist. Okay, and if it exists, we are going to go inside, like checking whether any favorites exist or not. So suppose the user clicks heart, uh, this song is favorited already. So if it is favorited already, or if it is not favorited already, if the user clicks the heart, I'll show the demo here. Login. Uh, mm, okay, I've not connected the backend. My bad. Okay. Uh, so uh, I'll show the demo. I'll show the demo. If the heart is clicked, it will check whether the favorite ID, the song which we have favorited right now, exists in the database already or not. So if the favorite exists already, we are going to remove it if the heart is clicked again. It is the toggle function. So this how does this filter work? So 101 is not equal to, let's say the ID or the song which we have favorited has the ID of 101 now, and then the database has 202. So how this filter will work? This if 101 is not equal to 202, so it will be true. So it will return an array which has 101 now. If 202 is like 202 is the one which is in the database, the 201 is the ID of the song which is already existing in the database and which we are now pressing the heart now. It will be false. This will turn out to be false because this is true. I mean 201 is equal to 202, but this because of this whole thing will become false. So this will remove it from the array and it will return 101, 202, 303 as 101, 303 alone. So what is the difference between dot sum and dot filter? Dot sum here, dot sum will just will detect the presence, but for transformation purposes or like changing the entire array mutability, we will make use of dot filter. Okay, then we are moving on. If the if like if it is removed, the heart is removed, we will make use of this. If it is hearted, we will push the song inside the favorites and then save it, and then view all those, and then export all these controllers for further purposes. That's it. Now let's take a look at the middleware which we have written. Okay, so this is the auth middleware which I have written, and then again we are importing .env JSON web token, and then the model which we have created for the MongoDB, and then .env.config, which we have seen all these before. Now what is a middleware? Middleware is something which exists between the front end and then the controller. So middleware, just like controller, has a request response cycle, but also an additional next. What is this? Next is a function which, when accessed, will help express move to the controller. Okay, so if we call the next function, the express will move to the controller. Okay, so if we send a response instead, the request just stops here. Okay, so now the tokens can be sent in two ways, either by using headers or by storing in cookies. Okay, so now we'll look at what these are. Okay, so uh, this is this is a request response cycle, and then inside that, okay, the headers, there are many headers inside the request. Okay, so they mostly, like, this is the header method where we'll be storing a token along with the header. So we are going to be storing the token using headers. Okay, so there are many type of headers inside the browser, as you can see, like general, request, and response headers. Now inside the request, there are many headers, and one among them is authorization header. So there are many headers inside the browser, and then there are like general request and responses, response headers, and one among the header inside the request is authorization header, and inside the authorization header we will have something called as bearer token. So what this bearer token is, we will be setting our token inside this bearer authorization header. So we will make use of split method. Okay, if there is no authorization header or the authorization header does not start with bearer, we can directly say that you are not accessing protected route, or you cannot say, you can say you cannot access this protected route because you are not authorized. There is a missing token. So basically we are no, defining the functionality of how we can enter a protected route. The protected route can be accessed because of this protect, uh, which we are going to be exporting soon. And then what this does is, uh, there will be headers, and then inside the headers there will be request header, and the request header will contain something called as bearer token. And then if the bearer authorization header does not contain a token or contain some other token, we are not authorized to enter the protected route. What is protected route? We will be looking while we are in the demo. Okay, so if we are logged in, we can access many functionalities of the website, right? That is one way of saying what a protected route is. Now we are going to be extracting the token from the bearer token. Okay, so we are taking the auth header and then splitting it by one. That is, that it will be of the auth header will be of form bearer and then token. We are splitting them so that it gives bearer and then the token, and then we are accessing the first index, so you get the token and then store it inside the token. And then we will be decoding this token using the jwt.verify. Whatever token is present in our database is it the same present here. Okay, and then and also the token must contain the secret jwt underscore secret of our environment. If it contains the same, then we can say that the token is a valid token, which was signed by the server once it was in this initial time it was given. And then we can log the decoded status, and then now we are now printing all the user details except the password. We don't no we are returning all the fields except the password. So find by id, we are getting the decoded token, decoded tokens ID we are getting, and then mostly the token consists of ID, secret, and then the expiration time, right? So expiration time, and then so we are getting the ID now, and then find by ID inside the user model we are checking whether this ID exists or not, and then we are returning all the fields except the password. If else we are saying not authorized, and then we are putting it inside the request.user. This is how the request.user works. So in controllers and all, we must have seen request.user all along, right? That request.user comes because of this middleware. So when you are saying request.user, this is what it means. We are getting all these this way, like except the password, we are getting all the fields, storing it inside the user, and then doing a request.user as saving the request.user with this user, and then we are using the next. So now it goes to the controllers. Okay, this is how it works. Front end requests something. To access the controller, we make use of middleware. Middleware calls the next function, and then the next function allows us to access the controller. That's how middleware works. If not, we can say token, the catches, we catch the error, and then we say token verification has failed or invalid token. That's it. So we can now see the routes present. We are importing all the controllers which we have written, and then these are the authorization routes. And this edit profile is a protected route, so we write it as protect. Then the get me also is a protected route, so we write it as protect. And then yeah, song routes. These are the song routes. We are importing all these controllers, and then yeah, that's it. These are the routes. So now we'll be taking a look at React hooks. So what are React hooks? Uh, all our applications need memory, and then side effects. What are side effects? We'll be taking a look at it. So first, there are DOM elements in JavaScript and inside the browser. So for getting access of the DOM elements and then storing the state and then re-rendering the whole UI when required, for all those things we need React hooks. There are many built-in hooks and then custom hooks that we can create. Some of the built-in hooks which I've used in this are use state, use effect, use reducer, use ref, and then since we are making use of the global store, which is the Redux, I've used Redux hooks as well, like use selector and then use dispatch, and I've also created my own custom hook which is use audio player. So I'll be starting off with use state. What is use state? Uh, uh, we have multiple datas, right? And then like if you want to say if you want to control one data, and then uh, over the due course we'll be storing the data and then updating the data as the user changes something within the UI. So for that we'll be making use of use state. So we'll be declaring it this way. First, it will take the value, and then we'll be making use of a function which will update this value, and then overall this state will be changed. This value is a state. So, so the value is the current state, and then set value is the function to update it. So when the set value function is acting, React re-renders the component with the new value. So we'll be getting a new rendered screen. We'll take some examples like storing songs. Suppose songs is the state, and then set songs is the function which will update the state. When we are getting the API response, set songs will update the song state with the results which is being fetched by the backend, and then initially this songs will be an empty array with the data coming from the backend. We'll have all the songs fed into the memory by the set songs. As soon as the memory is being fed inside, we will have React re-rendering the UI and displaying all the songs. And then we'll take another example. Let's figure out how search works. Let me show you how. Let me show you what I'm implying here. Uh, this is the music app, right? So if you go and search in, okay, first I need to log in. Mm, okay, I'll explain it first. So uh, first, query is the state, and then set query is the function. Initially, the query or the search. Let's suppose this is a search bar. Okay. Uh, Initially, this will be empty, and then uh, as soon as we enter something, the set query will start updating with this function. Like let's suppose user types in R or yeah R. This then the browser will fire an event. What event? An on change event. Like something has changed. So the browser will fire an event. React will receive the event object. As soon as React will receive the event object by this way, and then what it will do is feed the object into this set query function. So and then parse the target and then the value, and then now this set query will have this object destructured or not destructured, but the value being fed inside the set query, and then now this set query will update the state which is the query, and then now we'll have uh, inside that object, as you can see, e.target.value will now become R, and then the code runs, and then now the query will become R. Now since the state has changed, which is the query, React will re-render the component, and then we'll have a new value. What is the value? So in our code we have this input tag, okay, and then we have this on change event, okay, and then now this value will depend on this controlled component. This is a controlled component. What is a controlled component? React controls what appears in this input box. So when R is pressed, R will appear, and then related search results will appear in the display. So that's how it works. So the flow is first the keyboard input will be there, and then the browser will fire an on change event since the keyboard has given an input, and then this set query will uh, destructure the object and then feed the new state, and then the query state updates, and then React will re-render it, and then there is also this use effect which we'll be using inside. This use effect will be called when this query changes. Now since we have entered R, the query is getting updated because of the set query, and then due to that this use effect will now run, and then it will fetch songs. What is this fetch songs? It is a function which we have declared somewhere else inside our code, and then this fetch songs will call upon the required APIs, and then will fetch us the song based on the search query which we are giving. So this is the search pipeline: keyboard input, on change event, set query, the query state updates, React re-renders it, use effect detects change, API request is sent. Now Jamendo in the backend will filter out songs and then give us the response, and then the song is returned, UI will get updated. Another example, we'll have a look at how the UI is getting toggled. Now this open edit profile is our new state, and then set open edit profile is a function which we'll be using to update the state. Initially is set to false. Now when the set open edit profile is clicked, or rather the edit profile button is clicked, let me show you. Now this, uh, we'll be having an edit profile here when we log in. Give me a minute, I'll log in. No, let me create a new account. Now, since you have logged in, you can see this edit profile getting shown. Initially, this edit profile is set to false, and as soon as we click this, a new model opens. Uh, as you can see, this set open edit profile will set the model to true. Now, React will render the model. That's how it works. This whole use state works. Now, let's move on to use effect. A use effect is something which works based on dependencies. When the dependencies change, the code inside the use effect will run. Uh, Now we can have some examples to clear it. Like when the home page loads, the songs must be fetched. Initially, if we refresh the page, uh, as you can see, no song is being found. But after some time, the backend will run, and then it will show us all the songs. How does that work? It will only be working for one time. As soon as uh, as soon as the fetch initial songs, as soon as like what this empty array means is that it will only run for one time. That is when the component initially mounts. It will not be getting overflown with all the data again and again. No, it will not make many API calls, but only when the component initially mounts, it will fetch all the data and then show it here. So that's how this empty array works with use effect. It will fetch all the initial songs. This is a function which we have written in the backend. And then this is one example. We'll move to the next. Okay, use effect for search functionality, which I've explained previously. Now I'll be moving on to the next example, which is for syncing user profile data. When we have logged in, it automatically gives us this name and then this email ID. This is because of the sync which use effect is handling. When a user is present, it will set the name as user.name and then set the email ID as user.email, and then it depends on this state which is user. So and then it will fill in this form, and that's how this use effect works. Now we'll take a look at the next hook, which is use reducer. When we have multiple states, it will be hard for us to manage all the states individually. We'll be making use of use reducer in those cases. Suppose we have play or pause, current song index, shuffle mode, loop mode, etc. For all these are states which music player needs to manage. So we'll be making use of this use reducer. This thing, this is the state, and then this is the dispatch. So use reducer is simply, or rather, a reducer is simply a function that decides how should a state change when an action occurs. Like action will give us what is an action? Action is like a message will which tells us something has happened, and then how should a state change when that action is happening is being decided by this reducer. And we can have this example to clear the concept. Suppose this is the action type. So this switch works based on the action type. It takes in, okay, this function reducer takes in state and then action as its parameters, and then this action is an object, and then inside this object there will be multiple things. Let's suppose this action has a type, and then the types are play, pause, next, etc. Now, when the case is play, what what user does is, spreads all the states, other states, and then only changes this is playing. And then when it is pause, again it takes in all the states and then only changes this is playing. And then all the states only changes the current index. It does not make any changes to the other things. So this helps with managing multiple states across re-renders to be not affected or not to be handled. It'll give us ease of access. That's it. So, and then either if nothing happens, we'll be returning the state. That's how this reducer will work. And then what kind of actions can be dispatched? Like the actions can be dispatched this way, like dispatch, type play, type next. These are the actions, and then that action dot type will let us handle the action. Okay, and then reducer will update the state this way. That's the use of reducer. And why are we using use reducer in this music player? Because there are many interdependent states, and then it is perfect. We don't need to handle them individually. Now we'll move on to the next hook, which is useref. Normally React won't let us handle DOM elements like audio, etc. But with the use of useref hook, we can access the DOM elements. For example, there is this audio controller which HTML gives us, but we can't access this DOM element without the help of this useref using React. So what we do is create this audio ref object, and then we pull this in with the useref hook, and then now we can make use of this audio ref HTML DOM element with the use of this useref. And then some example commands can be audio ref.current.play, pause, whatever the HTML gives as functionalities, we can make use of it. And then we'll move to the next. Now let's take a look at Redux. So what is a Redux? Redux is like a central memory system where many states live, and then all these states are global, which means like when a React component is present, a state is not limited to that React component. It is not local. When we declare a state within Redux, it is accessible by all the components which can make use of Redux. So now, what does this Redux toolkit provide to us? It automatically sets up reducers or gives us tools which helps us set up reducers, and then gives us some middleware, and then many other things. So now what is a state? State, as we have discussed, is just the data, and then action is a message which tells us what kind of event has happened, so that the reducer can go and make changes to the state, and then the React can re-render. Now, what does this configure store do? This configure store is part of this Redux toolkit, it helps us set up many things like reducers and then middlewares, etc. Now, an important thing to note within Redux is that these reducers do not modify the existing state. It creates a new copy of the existing state and then make changes to the new copy and then gives updates the state and then re-render it. This immutability uh, helps Redux track changes. So, and then we configure the store, create a store using this configure store, and then we create reducers, and then we export the store. Now, basically, we have created a store which manages all the states within the slice that we are going to create, and then we have also created reducers which will work with those slices. And then we'll move on to the slices. Slices are like a part of the store, like which contains many states, etc. So now let's move on. This is the initial state, like user is null. There is no token inside the storage. If there is a token inside the local storage, we will be getting it, or else we'll be setting it as null. And then authentication is false, loading is false, error is false or null. We will now create a slice which is this auth slice by making use of the create slice, which is provided by the Redux toolkit again. And then we will create a slice. Again, what is a slice? Slice is a part of the store which will contain many states. Now we will have reducers inside this slice as well, and then some of the reducers can be like set loading, which will update the state to loading using the payload which will be getting. The payload will decide whether it is loading or not. For example, the payload may say it should be loading right now or else, etc. Now, and then this error is set to null when it is loading. This is one reducer, and then set user is another reducer which will act on the state objects, mini states. I don't know what to say, like user token, and all these are updated by this payload which is being provided by the action. And then similarly, we have many reducers inside this auth slice, and then we are exporting all these, and then we are also exporting this reducer so that it can be added to the Redux store as a whole. And then we also have UI slice, which is similar to the auth slice in structure, but serves different purpose. So Redux is basically a global store which manages all the states. So since we have discussed this Redux as well as uh, another React hook, which is uh, this one, use reducer. If you are wondering what is the difference between both of them, use reducer is limited to the limited to a single component. A single component might contain many states, and then use reducer will help us manage all those states, but it is local to a single component. But Redux is not like that. It is again going to manage many states similar to use reducer, but it is accessible by any components which gets their hand on Redux. So that is the difference between use reducer and Redux. Redux can be used by many components themselves, and then use reducer is just a tool which helps us manage many states within a single component. And then that's what Redux and then use reducer is. We'll move to the next React hook, which is use selector, which is being used by Redux again. Now suppose we have to retrieve data from Redux inside React. We will be making use of this use selector React hook, which we can be getting from React Redux, and then we can fetch all the data from Redux to React using this use selector React hook. This will be used in this way, like we will be updating the state, and then all other token. We are basically destructuring the object as per our wish, and then we are making use of use selector to get the state from the state.auth. Get the state from state.auth. which is present inside Redux. So example use cases can be to check whether the user is logged in or not, and then show favorite icon if the user is logged in, and then send authentication token in API requests, etc. And then another Redux based React hook is use dispatch. We might have seen dispatch inside the use reducer. Here, this is again local to a single component. Now, this use dispatch is useful for sending the dispatches between Redux and then React. When a React makes any change to say that an action has occurred, we make use of dispatch, and then that action will invoke the reducer to update the state and then eventually re-render the React. So we make use of this use dispatch provided by React Redux to update the Redux state. We make use of reducer like normal dispatch to update a local component using use reducer again, which we've seen above. This use dispatch is used for updating Redux state. It will be imported this way, and then it will be made use of this way. And then now we'll move on to how things function inside my app. Okay, so now we'll take a look at how all the functionalities work inside our app. Now, how the songs load when the app is started. As you can see, when I refresh this page or when I open my app for the first time, it loads this way, right? Now, after a while, all the songs load. As you can see. Hmm. Now as you can see, all the songs have loaded. How does this work? So, uh, first, the React will make use of use effect, which in turn inside it will have this dependency. That is, this component loads in the initial mount, or rather, it only works for the first time. Only once when the component loads. When it is like refreshed or booted in, only at that time this use effect will run, and then what it will run this function which is inside it. This function internally will have this Axios, which is a get request, and then it will get all the data from this API slash songs, and then inside it internally it will be calling Jamendo Music API to retrieve all the songs, and then this Axios.get will give us all the song data which is being given by Jamendo. Now, when the response arrives from this get request, we will be having response.data, or rather the response. We will collect the data only, and then we will in turn parse it and then get the results alone. And then we will make use of the set songs reducer to update the state using this is how the initial page loads the whole lot of songs. And then now we will move to song list rendering, how the songs are being rendered after okay, initially it will be just setting the songs, and now we need to display the songs, rather this should be displayed. For this, what it will be done is inside it we will be making use of a map which will render the song using the render song card .jsx, which is being present inside our code base. So all the songs will contain objects like ID, name, artist, duration, etc. Our React will make use of the song card component for all the songs which we have, and then it will create something like this: name, artist, year, duration, and all those things. Uh, After the set songs, set the data inside our memory, and then now when we click some song, it will trigger a function, And then now what happens when we click a song? When we click a song, after a while it will start playing. As you can see, it starts playing. So how does this happen? What will be internally happening is, we will, when we click, the index of the song will be captured by the React, and then React will call a function to play the song at that index, and then we will be giving index as the parameter for this function. This function, what it will do is update the current song state, update the player state, and then it will tell the audio element, which is the DOM, which will be accessing using useref to play the current song. And then now it will be making use of the HTML audio element, and then which is this audio ref dot current play, and then React will keep a track of the current song, current time, duration is playing, etc. states. And then this is how the song plays when we click it. Now uh, now we will move to the audio player controllers, like these. It contains album artwork, song name, artist, and then the control area contains play, pause, next, previous, seek bar. This is the seek bar, and then these states are being passed into the footer.jsx from homepage.jsx, and then when it is passed, it will have their own functionalities to update these states. Now how does this next song and previous song logic work? uh, Suppose we have 15 songs, and then we are in the 15th song, and then if we click the next button, React knows to move to the first song. But how does it know? Internally, we will make use of this next index is equal to current index plus 1 modulo songs dot length. So let's suppose we have only 15 songs, or rather 15 songs. When we do this 14 plus 1 modulo 15, it will go back to the first song. It will loop back to the first song after completing the playlist. That's how React knows what to do with next and then previous song when we are at the edge case. And then now shuffle mode. Shuffle mode will be generating a random number using the length and then possible values. And then we will generate a random number within the range, and then we will be giving that as a parameter to this play song at index. And then now playlist filtering. Now we have many workout, chill, happy. We have many playlists, and according to that, when we click, those kind of songs appear, as you can see here. How does this work? Each playlist internally is connected to a tag inside our code base, and then when we click on it, the tag is being fed to the API. This way, like APS slash song slash playlist slash colon tag, we are sending this as params, the tag as params, and now when we give the tag, Jamendo API will parse the params, and then it will be the API will pass the params, and then will be sent to the Jamendo API through the backend, and then Jamendo API will return all the responses related to the tag, and then we will be displaying those songs here using React. React replaces the previous songs, like let's suppose these are the songs, with new set of songs based on the songs which is being sent by Jamendo. Now, how does this play song favorite songs features work? When we click on this favorite, now we don't have any. Let's suppose this is our favorite song. We have favorited it. As you can see, now it is favorited. Now if we go inside favorite, we can see this being favorited. How does this work? Uh, this is being this heart icon which is being clicked, and then declicked is being done by handle click function. As you can see, it is now disappeared. It has now disappeared, and then it is being handled by handle like function inside. And then when we click the favorite, the song data, that is, suppose we like this song, the data of the song is being collected, and then it is being sent as post request, uh, and then the payload will contain the song details. Backend will make collect all those details and then save it inside our database. And then if it is clicked again, the heart is clicked again, the favorite is removed from the database. It is being updated by Redux. And then now, how does this edit profile work? When we click on this, we can upload some photos. As you can see here, we can upload this photo. Now this photo is being uploaded. Now save changes. It will take us a while because it will be sent to the cloud, and then there it will be saved, and then that URL will be saved inside the database. So it will take us some time. If our internet is correct, fast enough, it will be loading faster. So now, how does this work? How does this edit profile work? When we make some changes, the changes will instantly get updated in the database. How does that work? Now, when the user clicks on the profile, the model window opens, like edit profile, model window opens, and then existing user data is loaded, like these are loaded, and then now whenever a new thing is being updated, the API requests update database, update database. The API requests update database, and then so now instantly the edit profile will work, and then we will be making use of base64 format for storing the images in the server. And then now, how does Jamendo work internally? Jamendo is basically a giant music catalog with metadata attached to every track. We have many metadatas like artist name, album, genre, mood tags, and then keywords. So when we send something like this API slash song slash playlist slash params of which is tag, the backend converts these requests into Jamendo API queries, which we have written inside the backend. And then suppose this is the song metadata, it will have tags like rock, guitar, energetic workout. So even if we type guitar or energetic, the backend will convert it, and then that song will appear in either of those keywords which we type, if we type as per the in the search. So it will search this way. Jamendo will return all the songs which has the metadata keyword containing rock, or rather say guitar, energetic, etc. And then using the load playlist, we will be sending the tag, and then the tag will be attached as a parameter, and then the backend will make an API request to Jamendo, and then this is how it works. User clicks the rock playlist, front end sends the request. There is a get request which is being made to the backend, and then the backend calls the Jamendo API. Jamendo will filter the songs with tag rock. Responses will be given to us, and then front end will re-render and then update the song list. This is how it works. Now we will move to the login or auth part of app, which is basically the sign up. We'll start off with we will be asking the users to enter their password, email, name. As you can see, if we log out and then sign up, we will be asking these. If we already have an account, we will be moving on to the login page, and then as we will collect all those data, and then if the user uh, sets sign in, it will be sent as post request to the backend, and then the backend will perform various other steps, like it will validate the input, whether the email format is right, password is of minimum length, required fields are entered or not, and then it will do the pre-save, which is the hashing the password and then storing it inside the database, and then the whole user detail will be stored inside the database. And then since this is state, or rather a sessionless authorization, we will be making use of Java web tokens. We will be given an example token this way, which contains the user ID, expiration time, and then a signature which is being set by the backend for us. So the JWT token will be generated for us, and then it will also be stored inside the database. So whenever user tries to access it again, it will be verified with the token which is being present in the database. Now how does the login work? When a user logs in using this way, logging, the user enters the details like email ID and password, and then logging in, and then we will be sending the data as a post request with email ID and password, and then backend then receives all those things, finds the user in MongoDB, compares their password using bcrypt. Since we are doing a pre-save using bcrypt, we will be again using a bcrypt to compare the password. And then if it is valid, if the password and the details are valid, it will generate a JWT token, and then the token will be sent to the front end, so that now the front end can validate and then store the token. And then even if we refresh or close the browser or open the browser, since the token is being stored inside the local storage, we will be able to access our own auth profile, whatever, even after many times of refreshing or closing the browser. Common storage options can be Redux store, local storage, or cookies. Now, how does the protected routes work? Like add favorite or edit profile. We will be having a bearer token inside the authorization header. When the token is being when the front end request is made, there is a JWT token inside the authorization header, and then the middleware verifies the token. And then if the token is being verified by the middleware, token being verified by the middleware is correct, uh, then we will be extracting the user ID, and then now the user ID will be set, and then the request will be allowed for the protected routes. And then logout password, it is simple. We will be just removing the token from the local storage, and then since there is no token in the local storage, again we will go back to this way. Authorization bearer token will be verified using the middleware. Since there is no token, user ID will not be extracted, and then there won't be any request made so that we can access the protected routes.